The figure shows a conducting circular loop of radius A placed in a uniform perpendicular magnetic field B. A thick metal rod OA is pivoted at center O. The other end of the rod touches the loop at A. This is the point. So the rod is at O and at A. It is the other end A will be revolved on this circular path.
It's a loop.
Yes, this is the loop.
Sir, the loop will also rotate.
This loop,
So no, sir, that round.
loop will not rotate. That is stationary. This is stationary. Only this rod will rotate.
Okay, sir.
See, the center O and a fixed point C on the loop are connected by a wire OC of resistance R. So this loop have resistance R.
Yes, sir.
Okay. A force is applied at the middle point of the rod OA perpendicularly so that the rod rotates clockwise. So this rod will rotate clockwise at a uniform angular velocity. We have to find the force. How much force will be acting on that, we have to find out. Understand?
Yes, sir.
So, when a rod is rotated in the magnetic field, about one end, if it is rotated like that, the length is A. So, we derived one expression. Induced EMF is what? Half into
half
B
B omega L
B A square omega. Okay? Or B omega A square. So here this is connected through some resistance R. The equivalent circuit we have to draw like this. This provide EMF. This EMF will be in what direction? Come on, guess it. Got the point?
Yes, sir.
This is negative, that's positive, and some resistance we have to keep there. So how much current is passing through that?
E by R.
So current is equal to E by
R.
R. That means B omega A square by 2R.
Yes, sir.
Okay, that much current will be flow through it.
Yes, sir.
When this much current is flow through it, current carrying conductor held in magnetic field experience force.
BIL sin theta.
Yes, yes. I
Length of the rod.
LB. Okay, let us apply here. I means what? B
B omega
omega A square by 2R into A into
B. Magnetic field.
magnetic field.
B square omega A square
Right, A
A
cube.
cube by 2R.
So B omega A cube into B into what?
B square
B square
Yes, B square by
2R.
2R. That's the force exerted. Okay,
Yes.
right. This is the magnitude of force exerted on that. Consider the situation shown in the figure of the previous problem. Suppose the wire connecting O and C has a zero resistance, but the circular loop has a resistance R. This dark one, circular loop, that have a resistance R that is uniformly distributed along its length. Okay, the rod OA, this rod OA is made to rotate with a uniform angular speed omega. Shown in the figure, find the current in the rod. We have to find how much current is flowing in the rod. So in the previous problem, what they given, the magnetic field is B and the length of this rod is A. Length of that rod is A. When it is revolving, okay, this rod makes 90 degrees. That means,
It will be straight down.
yes, this is like this. The rod comes here and that is a C. This is the joining wire O and this is A. This angle they given it as 90 degrees. Okay. So this rod will generate EMF. In the earlier problem we decided a rotating rod will generate EMF. How much EMF generated? Half
B omega square.
B
Omega yes.
omega A square. That much EMF it will be generated. Now see here, whatever the current comes here, that will be,
Distributed.
yes, divided. When it is divided, the resistance of this one R1 and R2, they are connected like parallel. Okay.
So but the other end is not defined.
So this is connected here.
Oh, okay, sir. Okay.
Okay.
So then it's theta means you should use sector.
Yes, this is like a battery connection and these two A and C are 2 points. A part of current comes in this direction.
So length
A
of.
part of current passes through that. Okay, you understand?
Yes, sir.
So because clearly they given 90 degrees, this is 1
by
quarter.
1 by 4 pi r.
So this
Length
is
of
R by 4. They given R.
Yes, sir.
Entire circle resistance is R. Okay,
R by 4.
right.
3R.
This
3R.
one 3R by
4.
4. Come on, find equivalent. R equivalent is 3R by 4 into R by 4
By 3R by 4.
R, total resistance. On cancelling this, what do we get? 3R by
16.
16. So how much current it will flow through that rod? That is EMF by R equivalent.
3B omega A square by 32.
So yes, 32 B omega A square by,
Sir. 3R no, sir.
it's 3R,
Yes, yes.
comes here.
Yes, sir.
Okay.
Yes, sir.
D we need to find out.
No. Here 2 will come. That's wrong.
Since 6. So,
Yes,
sir,
yes. This is a half B omega A square by
3.
3R by 16.
Yes.
By 16. 16 goes to numerator.
6.
We
Then
can
8.
cancel 8. Yes. 8B omega A square by 3R. That's the current passing through this rod, whatever we attached. Okay. Here, this actually, why we are not taking a weight of rod?
So, because it is negligible. In
This is in horizontal plane. Horizontal plane. This diagram is in horizontal plane. Horizontal plane means actually like this. Okay. Here the rod. Here the rod. Okay. And this rod is revolving. So that weight will act in this direction.
Gravitational force will be
That won't change the theta.
Yes.
90 degrees.
And we apply force in this direction to rotate.
So if it is theta other than 90 degree means the weight of the rod will act as well.
No. This is in horizontal plane.
Force will always be horizontal.
And the question horizontal. And the
This is-
90 degree theta.
In the previous problem, they given it is in horizontal plane. Okay, let me show you. See where uniform perpendicular magnetic field. That's uniform perpendicular magnetic field. Understand?
Yes, sir.
And this entire arrangement is in horizontal plane.
They didn't mention, sir.
Hmm?
They didn't mention, sir.
A circular conducting loop, radius A, uniform Perpendicular magnetic field means what? Magnetic field perpendicularly like this.
Okay, sir.
Yes, sir, but
Okay.
giving orientation.
Horizontal.
They didn't give orientation of anything.
This is actually this is the perpendicular. This is the circular loop. A thick metal rod pivoted at the center. The other end of the rod touches the loop. The center O and a fixed point C on the loop is connected to the wire resistance. A force applied at the middle point perpendicular to rod, so that the rod rotates clockwise with uniform velocity omega.
Sir, I think MG will be acting, no, sir.
Mg definitely act, but
So no, sir. They didn't give horizontal, no, sir.
they not mentioned about that, because you need not take that one, because this is rod O and this is A.
So if this is kept like this, what will happen?
Yes, this is the weight mg actually,
Yes, sir.
and here force is we applied in this direction to move it.
Yes, sir.
To move it, the weight of this one acts perpendicular in this direction.
Yes, sir.
We applied in this direction force,
Yes, sir.
so that it will rotate.
So if we keep vertical, the applied force won't do anything, sir.
Applied force.
So if we keep this in vertical plane,
Ah,
the
what-
applied force will not do anything because it is hinges, sir.
Yes. Next problem is vertical plane only. This is in vertical plane. Okay. Let us do.
So in that, the applied force will not do any change, no, sir. In vertical plane.
See. Consider a variation of previous problem. Consider a circular loop lies in
Vertical plane.
vertical plane.
Only MG will be acting.
Mg will be acting on that. So rod of mass m. Here they mentioned rod mass.
MG sin theta, F cos theta.
Yes.
So MG sin theta will be MG sin theta plus F cos phi will be acting, no, sir. Total force.
Yes. Let us say rod how much angle it will make? The rod and the loop have negligible resistance.
They didn't mention, sir.
So rod and loop have negligible
Previous
resistance.
problem, loop had resistance R.
Yes. Connecting wire OC has resistance now. This have resistance, like in the first problem. Okay. And rod is made to rotate with uniform angular velocity omega in the clockwise direction by applying a force. Okay, rod is made to rotate uniform angular velocity in
Clockwise
direction by applying
force at midpoint.
force at midpoint of OA in the direction perpendicular to it.
Yes, sir.
Find the magnitude of this force when the rod makes
An angle theta with the
theta with vertical. Suppose this is the rod. This is the rod at that moment. This is the vertical. It makes an angle
theta.
theta. The weight of the rod acts vertically down. That's the weight of the rod. Okay. And if that is the weight of the rod, let us make it components.
Yes.
One component comes in this direction and another component comes in this direction. This is theta means this is theta. Got it?
Yes, sir.
So this is a
MG sin theta.
mg sin theta.
Yes, sir.
And this force will act in which direction?
MG sin theta direction.
Sir,
Along
they
with
didn't
it,
apply
So
for-
whenever it is revolving like that,
will go along with MG sin theta direction.
you have to apply right hand Fleming's right hand rule to decide that, because it is rotating with angular velocity omega, definitely EMF will be induced in it. That's a half B
omega.
A square omega. Okay,
Yes, sir.
right. And some current is also flowing through that.
Sir, applied force, sir.
We will decide that. Okay. So I is equal to I is equal to what? That's half B A square omega by resistance. This much current is flowing through that. Flowing through that. In which direction? We decided it is act as a cell off like that.
Yes, sir.
So that current will flow through it. Okay, current will flow through it. Come on, apply Fleming's right hand rule. Magnetic field,
Current force.
motion. Okay,
Right.
that means the current will flow in this direction. Current will flow in this direction in the rod. This is the direction of current flow in the rod. If that is the direction of current flow in the rod, current carrying conductor placed in the magnetic field.
Experience of force.
Yes, that is in which direction?
Down.
Fleming's
Left hand.
left hand rule.
This is
Magnetic field, current direction.
upwards.
So that means this is exactly opposite to this.
Yes. Sir.
That is the direction of force it will experience. That's Bill force. Okay. But the force, find the magnitude of this force. This force means what?
So there is one more force applied, sir. Additional force is applied, no, sir.
FPIL,
Sir,
Yes.
there is
Yes, sir.
additional force is also applied, no, sir.
Yes. Net force will be mg sin theta minus
Applying a force.
BIL means A.
Sir,
Mm.
sir, they gave in the clockwise direction by applying a force at the midpoint. One more force was also added.
Yes, that will be in this direction.
Yes, sir.
That's what I said, net.
Sir,
This force is responsible for
sir, net is the due to FBIL and MG, no, sir. They are saying net.
yes, this is a component weight of the rod.
Sir.
Because of current flow, this experience, this force.
Yes, sir.
What is the net force?
Sir, no, I'm not saying about that, sir.
Ah.
There's additional one more force is added, sir.
That force have to maintain omega constant means you have to kill this F net.
Okay.
Understand? Then only you can maintain omega
Constant.
constant.
Okay.
Understand? That's why we have to find F net. The applied force is equal to net force. So mg sin theta minus b into I means what? Again b a square omega by
2R.
2r. Okay. Got it.
Yes, sir.
So mg sin theta minus b,
A square.
yes, a square omega
Why 2R, sir?
by
1 by 2 da.
1 by 1 by 2.
Oh.
Already.
That is I. Okay.
Sir, R negligible.
And one more A.
One more a. Okay.
Yes, sir.
Right. Let us take mg sin theta
Minus B square, A square, omega.
B square.
A cube. A cube.
a cube
Omega by 2R.
omega by 2r.
Yes, sir.
2r. This is the net force. Okay. That is equal to applied force.
Sir, I think we left sin theta, sir. VIA sin theta should come now, sir.
Sin theta, because magnetic field is normal to that, that force becomes
1.
1. You know, F is equal
Yes,
to
sir, that I
BIL sin theta. Okay. This theta is what?
90.
Between, angle between the rod
Magnetic,
and...
magnetic field and length.
Okay, sir.
Magnetic field and length are perpendicular.
Okay, sir.
That's why this theta is becomes
1.
90. So the sin 90 becomes.
1.
That's why we simply used
VIA.
BIL. Okay. Understand?
Yes, sir.
This is your doubt.
Yes, sir.
So mg sin theta minus b square a cube omega by
2R.
2r. If it is horizontally moved, this mg sin theta component not there. First problem.
Yes, sir.
Let us move on to next problem. This one. Come on, see. Figure shows a situation similar to the previous problem. all parameters are same except that the battery of EMF E and a variable resistance R are connected between O and C. Neglect the resistance of connecting wires. Let theta be the angle made by the rod from the horizontal position. Okay, shown in the figure, measured in the clockwise direction. Clockwise direction. During the part of motion,
0 to pi by
0 to pi by 4. That means it rotated in between quarter angle. The only force acting on the rod are gravity, force exerted by the magnetic field and the pivot. However, during the part of the motion, resistance R is varied in such a way that the rod continues to rotate with a constant angular velocity omega. Find the value of R in terms of given quantities. That's the problem. So here, this is the additional EMF source that's connected.
Yes.
Is this additional source can send current in support of this rod?
No, sir.
No, sir, it is the
Because
EMF
there is
produces
no
reverse.
See,
EMF produced,
here we are revolving in this direction.
the EMF produced by the rod will cancel.
So rod motional EMF generated in this direction.
Opposite.
Yes, sir.
And this is connected to like this. That on this
Yes.
variable resistance. How much current will flow?
Sir, one.
Motional EMF is half into B A square omega,
By
and this is EMF source E we connected. So current passing through that is
E by
E
R.
plus, because both are trying to send current in the same direction.
Yes, sir.
This is positive terminal, positive terminal. This is positive terminal, that's negative terminal. This is negative terminal, that is positive terminal. So they will send a current in the same direction.
direction.
So you have to add their EMFs by resistance R.
R.
So that is E plus half B A square omega by R. That's A square omega by R. You understand this one?
Yes, sir.
Sir,
So
what
this-
about the resistance of loop? Sir? Negligible.
This is a resistance.
Of loop.
This one negligible. Okay. Only this resistance is included.
Other than the EMF.
Yes, and EMF.
Okay.
This rod does not have any resistance. This circular portion does not have any resistance. Only this resistance is going to vary. That value we have to find. When it will maintain constant angular velocity. When it will maintain constant angular velocity, when the net force is
Zero.
0. Okay. So here they given this is the rod position, and with the horizontal they given angle theta. With the horizontal, theta is angle made by the rod, the horizontal position. Okay. So when horizontal position, weight component comes in this direction, mg cos theta. Other component comes in this direction, mg sin theta. That's along the rod. We does not require that. Okay. mg
Cos theta.
cos theta. After that, what happens? We know that it will experience a force due to current flow, BIL. So because it has to rotate with a constant angular velocity, net force will be balanced. That means mg cos theta must be equal to BIL. So I means you need to substitute that V into E plus half B A square omega by
R.
R into L. L means A.
A.
Length of the rod A. So
Equals-
that is mg cos theta. So bring this R to this side. R is equal to You can write this as a 2BE
Yes, sir.
plus a B square A square omega
By 2.
and multiplied by A. A will be there
By
by mg cos theta.
2, sir.
Sir, 2, sir.
2 mg cos theta.
Okay, 2 mg cos theta. 2 mg cos theta. Okay, this is the answer for that.
Okay.